Hello there. I hope you're doing great. So in this video, we'll see how we can use the builder pattern in Golang. So builder pattern is a creational design pattern that is used to create complex structures or complex objects from small functions that are often chained together for the ease of use. So in this video, we'll build a response builder that we'll use to send responses from a server. At first, we'll return simple text responses. Later, we will expand that object to send JSON responses as well as sending files, image files or documents or even text files. And at the end, we'll expand that response package to send HTML templates as well. So let's start. So I simply added a handler to the slash route, and I simply printed the statement that we are starting the server at port 80, and we started the default server mux at port 8080. And here first we will write a simple text response using the standard response writer, and then we'll see that it adds on complexity, and we'll try to reduce the complexity through our package that implements the builder design pattern. So first, to change response status code, we use a write header function that I often find not so intuitive. And this w.header.set function is to add headers to the response. And this w.write function is used to send some response. And this write function accepts the data to be in a byte slice, and we have to typecast this string type into the byte slice. So this error shows because we haven't initialized the package with gomod in it. Now let's try to run the function. Now here it does give us the right response, and if we check the status code, it does give us the status code of 201, and it works fine. So let's try to implement the same logic in a easier fashion using the builder pattern. So I'll create a separate package. So I'll start by initializing a struct that will contain all the data that we would need to construct our response. So to create a simple response that returns a string, we would need these three details. And if you see closely, I have made this response struct data type as private. So this would not be accessed directly by the external packages. Instead, we'll create a new response function. And here we'll return the pointer to response for the space efficiency, and we'll add some defaults. We'll also initialize the header because not initializing it would give us some nil pointer exceptions, and now we'll create methods to update these data. So here we added the three functions that we'll use to update this data, and at the end we'll create a write function that will take the response writer and send in the final response from the server to the client. So now we'll do this in 3 steps. So first we'll update the status code, and then we'll update the headers, and at the end we'll just add the data. So let's try to replace this response with the response we had just created. So I find this type of construct much more readable. Let's try to run this. Okay, I'm sorry for the blunder. We haven't called the write function. and here it gives us the correct text and also the correct status. So oftentimes when creating REST APIs, we need to create a JSON responses. So let's try to make the JSON response function as well. So to optimize the data we are storing in here and to make this in an optimal way, what we'll do is we'll create a data type known as response type. And this response type may have two values, or it may have JSON response type. Okay, and we'll add a field in here in the response. So when sending the message, the value of a response type would be text response, and when sending JSON data, the value of response type would be JSON response. Also, the data type I'll change it to be an interface type, so that it can accommodate, it can take up any value. Okay, so now we can add the data value to this data. Okay, and while updating this data, we need to check for the response type field. If it is of the type text response, we can easily typecast it into a string, and we can convert it into byte slice, and then we can write that byte slice. If it is of the type JSON response, we'll need to call the JSON new encoder function, and we'll pass in the response writer, and we'll call the encode function and pass in the data. I suppose this should work fine. So now let's try to use that function. So to use, I'll need to create a struct, and we'll call the JSON function, and we'll pass a person with the names, let's say. Now let's try to run this. Now it does give us the response in the correct format as expected. So one more thing we need to do in here is, when rendering the JSON response, we need to set the content type header as JSON application.json. And one more thing we are ignoring here is, which we should not ignore, is the errors. While encoding the JSON, the Golang may encounter some errors, so we shouldn't ignore those errors. So our write function must return an error type, and also while writing this through the w.write, it may encounter error. So we should send those errors to the caller function so that it may handle it properly. So I'll create a error data type, and we'll just return error. And similarly, while encoding, this does returns an error type, and we'll simply return that. And at the end, we can just return. We'll just assign all these errors to this variable, and at the end, we'll just return the error. So we have already tested this. Now what I'm gonna add is, we often may want to return some files as a response. It may be some text file, or any image, or any PDF document file, audio, video, any of those files. So we'll also include that functionality in our response builder. So to return a file, the user will just give us the file path of the file, and we'll store that into the data field. And we also need to have another response type as file response. And now we also need to handle that case in here, file response. What we need to do is, we need to use the read file function from the OS package. So we'll typecast it to this from this to string the data, and this may return us the byte slice and error. So we'll initialize the byte slice first, and then we'll just write that byte size into the data. So if this opening file has some error, we'll simply return that error before moving forward, and if this works fine, then we can store this error in the error feed and it would be returned at the end of the function. Okay, so now let's try to test this. So to test this, I'll just add an image file here, and we'll just return this image file as a response. Now let's try to run this. You can see now when we open this, it does return us this image. So our file function is also working fine. So the last thing we want to implement here is to send in the HTML templates. Oftentimes when creating some dynamic websites, we tend to use templates, and we populate the data from databases or slices or anywhere inside those templates. So let's implement that. And here we'll pass in the HTML templates, which would be a type of template template, and it may also have some data that can be of any type, and as always it will return us a pointer to response. Now to use this template, we need to add another field. So one thing you need to make sure is that we are using the template package from HTML/template, not text/template. And now we just populated the HTML template and data with this, and also we need to populate the response type variable as HTML template response. Okay, and we also need to add in the case here. We just call the execute function, provide the response writer, and provide the data. And as always, this may have some error, and we assign that error, or we can simply return that error. And same thing with this, you can simply return that error. I think this should work fine. So now let's try to implement. Now let's try to use this function. All we need to do is just call parse files, and I'll just create a simple HTML template, and we'll use some template variables which we will pass. Okay, and now I'll use this template.go.html. So this is just a convention to add the extension of go.html to any go HTML templates. So I'm just using that here. Now this may give us a template and an error, and like any good programmer, we should handle the errors, not ignore them. I'll just use the HTML template function and just pass the template and also the data. As for data, I'll pass in a person, and let's try to run this. And it does give us the rendered template. So this was all. Now this response object can be extended to implement, let's say, markdown files, or maybe other types of files like XML files maybe, although they are not so commonly used these days, but it can do that as well. So you see, this pattern is quite extendable and quite easy to use, and makes the code much more readable. I hope you got to learn something new from this. Thanks for watching.